In part one of this program on aircraft ignition systems, we learned how high voltage was generated in aircraft magnetos, how it was carried to the spark plug, and used for ignition in the engine cylinder. In part two, we will discuss magneto timing, both internal timing and external magneto timing to the engine. After this, we will take up spark plug servicing and testing, as well as ignition lead testing. Each magneto has its own operational characteristics. Because of this, there are many ways of timing a magneto. But regardless of the details, internal timing essentially involves two steps. First, to time the distributor rotor to the rotating magnet. Then, time the breaker points to open at the exact moment the magnet reaches its E-gap position. The magneto we will discuss in this timing procedure is part of the Bendix S200 series. This particular model is made for a 4-cylinder engine and has a set of retard points for the shower of sparks ignition system. It rotates counterclockwise, as seen from the drive end. Because of this, it is called a left-hand magneto. The same distributor gear may be used on either a clockwise or counterclockwise rotation magneto. The difference, however, is the tooth that is meshed with the marked tooth on the magneto drive gear. Since this magneto has to turn counterclockwise, the indented timing mark and the chamfered tooth pointed to by the counterclockwise arrows are marked with red paint. The drive gear on the magneto should be installed with the arrow pointing in the proper direction of rotation. Again, this is as we view it from the drive end. The dot by the counterclockwise mark on the distributor gear is aligned with the marked tooth on the drive gear, and the gears are meshed. We must remember in this training program, we are concerned only with the timing procedure. All other assembly details, such as lubrication and bearing preloads, must be performed according to the manufacturer's overhaul manual. Now, with the two gears properly meshed, the painted, chamfered tooth will be visible in the timing window. By doing this, the distributor is in the correct position to fire cylinder number 1. At this point, the cam is slipped onto the shaft, with the arrow pointing to the proper direction of rotation. Then secure it with the correct washer and screw. When the marked tooth is centered in the timing window, the rotating magnet has a tendency to back away slightly. Allow it to find its place of rest, which puts the magnet in its neutral position, which is about midway between the pole shoes. Hold the magnet in this neutral position and install a rotor holding tool on the magneto drive to lock the rotor. Now, put both the main and the retard breaker assemblies in place, with the main breakers in our counterclockwise magneto on the left side. Do not tighten the securing screws yet, since a few adjustments have not been made. Use the correct timing plate. Slip a pointer over the cam retaining screw and set the pointer to 0. This indicates the neutral position of the magneto and is the point where we will reference our timing. Loosen the rotor lock and rotate the magnet counterclockwise until the pointer aligns with the proper E-gap angle. In this case, it is 10 degrees. Now, relock the rotor. Connect a timing light across the breaker points and adjust them until they just open. Then, tighten both contact securing screws. Loosen the lock and turn the rotor until the highest part of the cam is under the cam follower. Now, measure the clearance between the breaker points. It should be within the limits set in the overall manual. If it is not, and cannot be adjusted to within these limits without causing the points to open outside of the E-gap tolerance, the breaker assembly must be replaced. Next, loosen the lock and return the magnet to the location at which the main breaker points opened. Note the reading and rotate the magnet counterclockwise the exact number of degrees specified as the retard angle. In our example, the main breaker points opened at 10 degrees, with a 25-degree retard angle required. So the rotor can be re-locked with the pointer at 35 degrees. Adjust the retard points until they just open and tighten the two securing screws. Unlock the rotor and rotate the magnet until the cam follower of the retard points is on the highest point of the cam. Measure the point opening with a feeler gauge. It must be within the tolerance specified in the overhaul manual. If it is not, the timing procedure must be repeated, using the minimum E-gap angle if the clearance is too small, or the maximum E-gap angle if the clearance is too large. Now that both sets of breaker points have been timed, the leads from the coil and capacitor should be attached to the proper terminals. At this point, give the magneto a complete inspection to be sure it is ready for installation on the engine. But before we consider timing the magneto to the engine, let's check our understanding of internal timing by answering a couple of questions. Where is E-gap in relation to the neutral position of the magnet? Is it at the neutral position of the magnet, before the neutral position, or after the magnet has passed its neutral position? The correct answer is after the magnet has passed its neutral position. The E-gap angle is that position beyond the neutral position of the rotating magnet at which the primary current is the greatest. Also, it is the point at which the breaker points are timed to open. Interrupting the primary current at this time produces the greatest change in flux and generates the highest secondary voltage. Next, besides the time at which the points open, what must be checked when internally timing a magneto? Is it the time the points close, or the maximum amount the points open? The second choice is correct. The maximum amount the points open must be checked. Now that we have correctly timed the magneto internally, we are ready to install it on the engine. First, we must remove one of the spark plugs from cylinder number 1 and rotate the engine in its normal direction of rotation. Do this until air blows out of the spark plug hole. This indicates that the piston is moving outward on its compression stroke. By using the number of degrees of ignition advance noted on the engine nameplate, the propeller can be moved until the timing marks on the starter ring indicate the crankshaft is at the correct number of degrees before top center. Once this is accomplished, rotate the magneto drive gear until the marked chamfered tooth on the distributor gear is visible in the timing window. By holding the magneto in this position, it can be slipped into place with the proper washers and nuts placed over the studs and turned down snug but not too tight Now, attach a timing light across the breaker points and rotate the magneto in its timing slots until the light indicates the points have just opened. Be sure that all backlash is out of the gears, and then rotate the magneto in its slots in the opposite direction. Do this until the light indicates the points have closed. Then, back in the original direction until the light indicates the points have opened. At this point, tighten magneto mounting nuts. To check magneto synchronization, connect a timing light to both magnetos and rotate the propeller in the direction opposite normal rotation until both lights indicate the points are closed. Then, very slowly, rotate it in the proper direction until both lights indicate the points are open. They must be together within the limits allowed in the aircraft service manual. If a magneto is equipped with an impulse coupling, you may check its timing by rotating the engine in the direction of normal rotation until the impulse coupling snaps. Then, attach a timing light across its breaker points and rotate the engine backward until the timing light indicates the points are closed. Now, the propeller may be bumped in the direction of normal rotation until the light indicates the points are open. This indicates the points are just braking without the influence of the impulse coupling. After this timing check is completed and the harness and ignition switch leads are installed, all of the installation must be inspected. The engine is cowled and a check is made to determine that the engine will develop its proper static RPM, and that the RPM drop when operating on each magneto independently is within the limits specified in the aircraft service manual. Finally, with the engine idling, check to be sure that the ignition switch cuts out both magnetos when in the off position. The final step in any aircraft maintenance operation is recording the work performed in the aircraft maintenance records. At this point, let's take a moment to review magneto timing to the engine. What is the meaning of the marked tooth visible in the magneto window? Does it identify the E-gap position of the magneto? Or does it identify the cylinder number 1 position of the distributor? The correct answer is, when the marked tooth on the distributor gear is visible in the timing hole, the distributor is in the correct position to send high voltage to cylinder number 1. Now we are ready to review spark plug servicing. Here we will define the proper method of cleaning, gapping, testing, and installation of shielded spark plugs. When spark plugs are removed from an engine, they should be placed in a numbered rack. This will help you identify the cylinder from which they came. This is done because the condition of the spark plug actually tells the condition of a cylinder. For example, if the firing end of the spark plug is covered with a relatively thin brown or tan deposit, it indicates that the cylinder has been firing normally and there's been no serious problems. But if all plugs are filled with hard, clinker-like deposits, it indicates that lead fouling is a problem. Very likely, these plugs have a cold heat range and should be replaced with plugs which allow the nose core insulator to run hotter. This will prevent lead deposits condensing inside the spark plug. If, however, the nose core insulator is covered with a black, fluffy soot, it indicates that the cylinder was being operated with an excessively rich mixture, or, again, the spark plug could be too cold for the engine. If the carbon deposits are oily, there could be damage inside of the cylinder. This damage is usually broken piston rings or excessively worn valve guides. In any event, a detailed investigation should be made of the cylinder from which the oily plug was removed. Before spending any time cleaning spark plugs that may have to be replaced, examine the electrodes carefully for excessive wear. If the ground electrodes are eroded away to 1/2 of the thickness of a new one, or if the central electrode is flattened by as much as 15 thousandths of an inch on each side, the plug should be replaced. Fine wire spark plugs present another problem. If the electrodes are worn away to 1/2 of their new dimension, the spark plug should be replaced. Now, examine the inside of the terminal cavity with a flashlight type magnifying glass. Check to see if there are any cracks in the insulator. Even the slightest crack is reason for rejecting the spark plug. Those spark plugs that pass the visual inspection must be degreased. This is accomplished by soaking their firing end in mineral spirits, such as Varsol or Stoddard solvent. But be sure that while soaking them, the terminal cavity is kept clean and dry, because film left from the solvent can short out the plug. After the plugs have soaked for 20 to 30 minutes, they should be removed and thoroughly dried with compressed air. The dry spark plugs can now be cleaned by very light abrasive blasting in a spark plug cleaning machine. Be sure, however, that only approved spark plug cleaning compounds are used, and that they are blasted for minimum amounts of time. This is because as little as 5 seconds of an abrasive blast can wear the electrodes equal to a couple of hundred engine operating hours. After the plug is cleaned with an abrasive blaster, use compressed air to remove all traces of abrasive material from the shell cavity. Most cleaning machines have an air valve for this purpose. If there are still lead deposits which were not removed by abrasive blasting, they must be removed with a vibrator type cleaner. With this unit, the proper blade is inserted into the plug firing cavity, where it is vibrated to break out these lead deposits. After these deposits have been broken out, another light abrasive blast and an air cleaning will remove the residue. After the inside of the firing end is clean, a fine wire power brush may be used to clean deposits from the threads. But remember, when using this brush, do not brush the electrodes. The inside of the terminal cavity is cleaned with a special rubber cleaning tool driven in a drill press. A water-soluble abrasive must be used to scour all traces of contamination. As a spark plug fires, the electrodes are worn away. This increases the gap spacing. The greater this distance, the higher the voltage must be to jump the gap. So, when spark plugs are serviced, this gap must be restored to its original distance to allow the entire ignition system to operate efficiently. When closing this gap, remember it must be kept parallel to provide the maximum amount of area for wear and usable time. For proper gapping, a special gapping tool should be used to carefully move over the ground electrodes and close the gap the proper distance. Be very sure that no pressure is applied to the center conductor. This is because it is mounted in a glass-hard, brittle ceramic insulator. Measure the distance between the two electrodes with a round wire-type gap gauge to be sure the gap is uniform throughout. Special care must be exercised when adjusting the gap on a fine wire spark plug, because even though both platinum and iridium are extremely tough, they will not tolerate being bent back too often. A special gap setting tool may be used to move the ground electrode over, but here again, avoid placing pressure on the center electrode. After the gap has been adjusted, it is also measured with a wire-type go, no-go gauge. The smaller wire should slip through the gap, but the larger one should not. After spark plugs have been physically inspected, cleaned, and gapped, they must be electrically tested before being returned to service. A combination cleaner and tester is used in most shops. Here, the spark plugs are screwed in finger tight to allow some air to leak past the threads. This allows the ionized air to escape and make the test more valid. Depress the high voltage test button and slowly increase the air pressure in the test chamber while you watch the intensity of the spark in the mirror. Adjust air pressure until the most intense spark is jumping across the gap. If the spark plug is electrically sound, the air pressure will be in the green portion of the dial. This indicates the spark plug will spark in the cylinder of the aircraft engine. After plugs have passed these tests, they are ready to be reinstalled in the engine. To begin with, brush rust preventive oil on the lower threads of the shell. Be sure, however, that none of it gets into the firing end cavity. Slip a gasket over the shell threads, and the spark plug is now ready to be installed. Be sure to use a new gasket, since the efficiency of the seal depends on how much the copper gasket is compressed. Used gaskets are hard, provide less compression, and usually leak. An aircraft magneto produces alternating current. This means the polarity of every other spark reverses. On an engine with an even number of cylinders, every spark in a cylinder has the same polarity, and thus concentrates electrode wear on either the ground electrode or the center electrode. To even out this wear, plugs should be returned to the cylinder next in firing order and swapped from bottom to top. For example, in a 4-cylinder engine with a firing order of 1, 3, 2, 4, the plug removed from number 1 cylinder top would go back into number 3 cylinder bottom. The one out of number 3 bottom would go into number 2 top, and so on through the firing order. The spark plug should screw into the threads in the cylinder head all the way down against the gasket. This should be accomplished by using your fingers only. But if there is any carbon or other contamination in the threads that prevent the plug from screwing in easily, it should be cleaned by running a thread cleaner through the hole. When doing this, if the flutes of the cleaner are filled with grease, the loose carbon will embed in it rather than dropping into the cylinder. When all plugs have been installed in the cylinders, they should be tightened with the use of a torque wrench, set to the torque value specified by the engine manufacturer. After this, ignition leads can be installed after wiping the cigarette clean of any fingerprints or any traces of grease, using a rag slightly damp with an approved solvent, such as trichloroethylene. Insert the ignition lead into the spark plug. Be careful, however, that it goes in absolutely straight. Then, tighten the lead nut to the proper torque value. After all spark plug leads have been installed and properly torqued, the cowling may be replaced, and the engine given a run-up and a magneto check. If the RPM drop is correct on each of the magnetos and the engine produces the proper static RPM, an entry is made in the maintenance records for spark plug servicing. At this point, let's review a couple of questions about spark plug servicing. What should be done if all of the spark plugs removed from an engine are excessively lead-fouled? Should you replace them with spark plugs having a colder heat range? Or should you replace them with spark plugs having a hotter heat range? The correct answer is replace the spark plugs with the type which has a hotter heat range. One of the reasons for lead fouling occurring was the nose core insulator was not operating hot enough to prevent lead deposits forming inside the firing end. A spark plug with a hotter heat range will not allow these deposits to form so readily. Secondly, what should be used to wipe off spark plug lead terminals? Should you use naphtha, carbon tetrachloride, or trichloroethylene? The correct answer is trichloroethylene. Naphtha leaves a film, and carbon tetrachloride is harmful to the person using it. Now for the last question. What is the best way to remove heavy lead deposits from the firing end of a spark plug? To use abrasive blasting? Breaking the deposits out with a vibrator cleaner? Or soaking the deposits loose with a decarbonizer? The correct answer is B. Break the deposits out with a vibrator cleaner, and then remove residue with an abrasive blast. Some ignition system troubles may be caused by the magneto, and some by the spark plugs. But the link between them, the ignition leads, must also be carefully examined where there is an ignition problem. Since the ignition lead must conduct high voltage from the magneto to the plug, it must withstand the electrical pressure without leaking. If there is an ignition system problem, examine the entire harness for indications of physical damage. Then, use an electrical leakage tester to determine whether the insulation resistance is high enough and there is no leakage within the harness. Be sure there is no oil or grease on the terminal end of the lead, for even a fingerprint will provide enough oil to cause high voltage to leak off to ground before it can build up enough to jump the gap in the plug. We have now seen the workings of an aircraft engine ignition system and can begin to understand how proper maintenance affects the reliability and performance of this vital system. It is hoped through this training series your ability to maintain these systems has increased. For it is only through your efforts as a professional aviation technician that smooth engine operation and safety in the air can be obtained.